Transformations. The graph of a function can be transformed either by shifting, stretching or shrinking, or through reflection. The elementary transformations of a function f are captured in function notation as follows. For translations, when shifting up or down, we have f of x plus k. When shifting left or right, we have f of and then x minus h in parentheses. For distortion, if you're stretching or shrinking vertically, it's given by a times f of x. If you're stretching or shrinking horizontally, it's given by f of b times x in parentheses. For reflection, when reflecting over the x-axis, we have negative times f of x. If we're reflecting over the y-axis, we have f of negative x. When shifting the graph of a function f of x up or down, it's given by f of x plus k and is called a vertical translation. If k is greater than 0, then the graph of f of x shifts up k units. If k is less than 0, then the graph of f of x shifts down k units. Consider f of x being x squared, this blue function down here. G of x is equal to f of x plus 2, which would be equal to x squared plus 2. Notice how it shifts up 2 units. And we have h of x is equal to f of x minus 3, or x squared minus 3. Notice how it shifted down 3 units from the original function f's vertex. Shifting the graph of a function f of x left or right is given by f of and then in parentheses x minus h, and this is called a horizontal translation. If h is greater than 0, then the graph will shift to the right h units. If h is less than 0, then the graph of f of x will shift to the left h units. Notice here how the original symbol in between the x and h is a minus sign. So let's actually consider some transformations that we have here. And I'm going to come back to this minus symbol in here and how it relates to the movement of the graphs as we examine them. First, we have f of x being equal to x squared, the main parabola that we have. And we have two of its transformations. G of x is equal to f of, and then in parentheses, x plus 2. That's equivalent to f of x minus negative 2. Notice how g shifted to the left 2 units. It's because that minus a negative, which makes a plus sign here, is why it shifts to the left 2. And then for h of x, we have f of x minus 3. So we went 1, 2, 3 units to the right because 3 is a positive number. So again, the graph of g of x is the result when f of x moves to the left 2 units because minus a negative is equivalent to adding a positive. And the graph of h of x is the result when f of x moves to the right 3 units. Sometimes we can have translations that show both a left and right movement as well as an up and down movement. The translation of the graph of a function f of x is given by f of and then in parentheses x minus h plus k. This includes shifting both up and down from the k value as well as left and right from the h value. So consider f of x is equal to x squared, our main basic quadratic function. And we have g of x being equal to f of, and in parentheses, x plus 2, and then plus 1. Notice how g of x is the result of moving f of x to the left 2 units, or going 2 in the negative direction. Remember, we have minus negative 2, which is why it became a plus 2. And then we have 1 unit up, plus 1. So left 2, up 1. That's how we got to g of x. And then we have h of x is equal to f of, and then in parentheses, x minus 3, minus 1. The graph of h of x is the result of moving f of x to the right 3 units and down 1 unit. Now let's talk about reflections. Reflecting the graph of f of x across the x-axis is given by negative times f of x. So if we had f of x being equal to the quantity x minus 2 squared, and we reflect it across the x-axis, g of x, which is the negative of f of x, would be equal to the negative of x minus 2 in parentheses quantity squared. And then if we're reflecting across the y-axis, it is given by f of negative x. So again, if f of x is equal to the quantity x minus 2 squared, and we reflect it over the y-axis, we put a negative only in front of the x. So it's negative x minus 2, and that in parentheses squared, which is equal to x plus 2 quantity squared.